Alright guys, welcome back. Today we're going to talk about volumes of similar figures. As you know, we saw length and we saw area, and today we're going to talk about volumes. The scale factors between the two lengths, if we say k, then we see that area we got k squared. Then you probably will imagine that for volumes, you're going to see k cubed. Is this the case? Let's go ahead and find out. So let's look at this cube boy over here. From 3 to 6, our scale factor is 2. Notice that guys, in the future, whenever you see scale factor, we're always comparing the length only. And then, let's find out the volume for each one of them. For A, we're going to have 5 times 3 times 2. That's going to give us 30. For volume of the bigger one, the red one, we're going to get 10 times 6 times 4. This is going to give us 240. And as you see, from here to here, you actually see we multiply by 8. That sounds very good. Let's look at the other one. If you go from the black ball to the red ball, by the way, this is 6, and this is equal to 2. Okay, if you're going from 6 to 2, the scale factor is equal to 1 over 3. What is my O volume? Remember the volume formula is 4 over 3 pi r cubed. So we plug it in. We're going to get 4 over 3 pi r is 6 cubed. This is going to give us 288 pi actually. On the other hand, the volume of B, we're going to have 4 over 3 pi times 2 cubed. This is actually going to give us 32 over 3 pi. Now if you do a little bit of math, you can see that pi and pi will cancel out. And then we actually multiply by 1 over 27. That looks very good too. So that leads us to this general case. When we talk about our scale factor, we're talking about k in this case. Notice that from h to kh multiplied by k, from r to kr we also multiply by k. Okay, but then when we're talking about the volume of A, again, the volume of a cylinder is pi r squared h. Okay, so we're going to use that. In this case, we're just basically going to get pi r squared h. Okay, nothing special. But for the new volume, you're going to get pi. Your r becomes a kr, so we're going to substitute that kr. Okay, our h also becomes kh. So basically, we substitute the r with kr, h with kh. That will give us pi times k squared, r squared times k times h. If we get rid of the pi r squared h together and put all the k at the front, we got k cubed times pi r squared h. But notice that this is actually our O volume. So that being said, we have our general rule on the bottom. Now, instead of having k squared, we actually have k cubed. So we're going to go over 2 examples today. Part A, we're going to find out the volume. First of all, from 5 to 2, our scale factor is equal to 2 over 5. Okay, we'll keep that in mind. That basically means if you want to go from this 100 to this x, we actually need to multiply by 2 over 5 to the power of 3, because we're talking about volume now. And that gives us x. Okay, so x is equal to 100 times 8 over 5 to the power of 3 is 125. And that gives us x. Cancel things out. We got 4 and 5 over here. X is equal to 32 over 5, which is equal to 6.4. Part B, we don't actually know what our scale factor is. This is equal to k. But we know from the old volume to the new volume, we multiply by 8. That means 10 times k to the power of 3 is going to give us 80. That basically means k to the power of 3 is equal to 8. That's a nice number in terms of cube. K equals to 2. So that means in order for me to get from 3.5 to x, I just need to multiply by 2. Okay, so 3.5 times 2 is going to give me x is equal to 7. Question number 2, we have a more complicated question from the textbook. We first of all introduce an idea of density. Density is a ratio of mass to volume. So basically we got this. Density equals to mass divided by volume. The key sentence is over here. Objects made of the same material have exactly the same density. So that being said, later on when you see any change of mass or any change of the volume, as long as we're talking about the same object, we need to make sure that our density stays the same. So let's read the question first. What will happen if the mass, if the radius is doubled? Let's do part 1 first. Okay, we're talking about the case where the radius is doubled. Okay, so let's call our original volume V naught. Okay, V0 is basically just 4 over 3 pi r. Okay, so our r is the original r, and with the original r, we named this volume V naught. Okay, we want to find out what happened to the volume if the radius is doubled. So in this case, we're going to find out what happened to, let's call y1. In this case, I'm changing my r to 2r. Your v1 basically is everything the same, 4 over 3 pi something cubed. And your r is going to become 2r. If we do that, this is going to bring us to 4 over 3 pi times 8 times r cubed. If we collect everything, same as the original, you're going to get 8 times 4 over 3 pi r cubed. This 4 over 3 pi r cubed is exactly our v naught, or v0. This means our v1 is actually 8 times of v0 or v0. Since we need to make sure that the density is always the same, we're basically saying that no matter what mass you have, even though you have a mass original and volume original, even if you change that to a new mass and a new volume, the ratio needs to be exactly the same. You can think about this as a scale factor. Okay, so what happens to the mass in this case if your volume is A times, right? So originally I have a mass original and a volume original. I don't know my mass original. I don't quite know my volume original either. I only know that this is 4 over 3 pi r cubed. But I only know that they have to be equal, right? So the m1 over v1 has to be equal to m0 over v0. But then now I know that my m1 is basically A times of v0. Okay, so if you look at these two, that needs to be the same. We realize that we can cancel out the v0 on the bottom. So that basically means you have m0 equals to m1 over 8. That being said, your new mass is going to be A times of the original. Okay, so you will say the mass will be A times of the original. So that's part 1. Part 2, pretty much similar, except the number is a little bit tricky now. We are going to find out what happened to our volume first, and then we're going to talk about mass later. Okay, so what happened to our volume? First of all, our radius is increased by 20%. That means this becomes, if you say you increase by 20%, that means you are 1.2 times of yourself. Okay, so in that case, your V2 is going to be 4 over 3 pi r cubed. Instead of using our r, we're actually using a 1.2 r. Okay, so 1.2 r, the whole thing to the power of 3. This is going to give us 4 over 3 pi times 1.2 to the power of 3 is 1.728 times r to the power of 3. Again, we combine the original 4 over 3 pi r cubed. This is going to give us 1.728 times 4 over 3 pi r cubed. Remember, this is still our v0. Okay, so basically it means this is 1.728 times of the v0. So once you increase your radius by 20%, your volume is going to increase by 72.8%, if you put it that way. Okay, if your volume increases 72.8%, that means your mass also has to basically increase by 72.8%. Because we need to have m0 over v0 equals to m2 over v2. Remember, the density always needs to be exactly the same. But then your v2 can be actually replaced by 1.72a v0. That basically means the same thing. We can actually cancel out v0 or v0. And we're going to get m0 equals to m2 over 1.72a, which is the same as 1.72a m0 equals to m2. This is basically saying that your new mass is going to be 1.72a times of the original mass. That's basically saying that your mass will increase by 72.8%. And that's it for this question. Let's take a closer look. This question is slightly trickier than other questions. Otherwise, that's it for today. I'll see you guys in the next lesson. Peace.